Hello and welcome to More Interesting Maths. I'm David Myers with UTC South Durham. In this series we are looking at GCSE mathematics. This is for those of you that want to revise for your summer exams, catch up on any materials that you may have missed, or if you're a parent that's wanting to help your kids out at home. Generic introduction clip over, now let's do some maths.
Today we are going to go through one of my favourite topics in mathematics. Not necessarily because it's originally the most applicable. It's not something that you can immediately go out into the wide world and do something fantastical with. It's because it expands into all of that. It's one of the great building blocks that helps us do loads of weird and wonderful things, both in the real world and just in maths for our curiosity. To begin with, however, what I want you to picture is a bag. And in that bag, you have got 2 eggs and £4 coins. 2 eggs, £4 coins in this bag. Then say, for instance, that you have 3 of these bags, 3 identical bags. What do you have altogether? If you've done some quick mental maths, then you would be able to say, well, in your weird bag, David, you have got altogether 6 eggs and £12 coins. And you'd be absolutely right. And looking at this puzzle here, 3 lots of 2 eggs plus £4, see what I did there? Altogether, we would have 6 eggs plus 12. Another way we can write that, while you're sat there going, okay, crazy David, well, you've obviously got 3 bags with 2 eggs and 4 quids in them. And you can write that quite happily as 3 lots of, in the brackets tell us that we've got 3 lots of whatever's in our weird bag, and that in this case is 3 lots of 2x plus 4. So which one's right? Well, actually, it's both of them. Both of them are saying exactly the same thing. And we'll come back to that in a bit. Another way that you can think about it is area. What if, in this case, I have some strange rectangle where the height is 4 and the total length is made up of 2 and x? 2 plus x would be another way of saying it. Well, actually, that answers the question right off the bat. The area of the whole rectangle we can write algebraically as 4 lots of 2 plus x, because 2 plus x is the whole length of that rectangle. Alternatively, we could try and be a little bit more explicit, because we know that the area of this on the left would have to be 8. There's no 2 ways around that. We know what the width is and we know what the height is. We know that the area must be 8. But because we don't know what x is, we can only sort of say that the area of that rectangle would still be 4 times x, and that would give us 4x. But we would know that we can still add the areas together. So we can still say that the total area for this shape is 8 plus 4x, regardless of what x is. What you've effectively figured out there is the mathematics behind expanding brackets. And this is an incredibly powerful tool that crops up left, right and centre. From here, right the way through to degree level maths, through A-levels, masters, you name it, expanding brackets comes into play. In engineering, in satellite understanding, everything, expanding brackets will get involved. So if you get your head around the basis of this, you've opened up the path for loads of maths that we're going to encounter in the future. Let's have a look at a few of the examples then. What I will do is very neatly show you how the geometric version, that was drawing the rectangles, links in. This 2 plus 5x, it does tend to help with your working, I think, if you draw a picture of it. We know that we've got this weird length on the top, which would be 5 plus x. So we can call that a 5 and an x. And we know that the height is 2. So we can split that right down the middle, and we can say this length here is 5. Doesn't have to be perfect. 2 times 5, that would give us 10. And 2 times x, that would give us 2x. Therefore, expanding these brackets, we get 10 plus 2x. And if I very quickly find my arrow again, we have that in its expanded form. You don't need to do anything else with that. It's not 12x. Remember, you can't just combine pound coins and eggs. You can't combine 10 and 2x. You just leave it well enough alone. What about something slightly trickier, say 7 lots of 2x minus 3y. 7 times 2x, that will give us 14x. 7 times negative 3y, that would give us negative 21y. You're just multiplying at this point, folks. Making it slightly trickier, 2x times 3x, if you watch the video on algebraic extractions, you'll be able to get this fairly quickly. 2x times 3x would give us 6x squared. And 2x times 5xy would give us 10x squared y. What about down here? Makes life slightly easier because we're doing 8xy times 1, which is just 8xy. 8xy times negative 3xy, that will be 24x squared y squared. So do it in steps. You can write it down as you're going along. If at any point you're getting confused, just scroll back to the first part of this slide and you'll see how it gradually gets a little bit more complex. Half x times x plus 4. Tempting to think that's a bit scary. Well, actually, that's just a bit of fractions work. What's happened there? The x times the x is x squared, and we've kept half at the front. A half times x squared. We don't know what the x squared is, so we can't very well half it. What we can half is this 4 here. A half of x multiplied by 4. If I were to just say a half of 4, you'd tell me that that's 2. So a half of 4x is 2x. You can half the number in this case. What about if we have to deal with something slightly trickier? Dealing with a negative sign. That tends to throw a lot of people out. The nice little hint that we can get from that is chucking a 1 in front of it, as in treating the minus brackets as minus 1 lot of these brackets. You need to think back to your numeracy here. Minus 1 times x, that would be minus 1x or minus x. A minus times a minus is a plus, meaning that this would become a plus 3. Altogether, therefore, we have minus 1x plus 3, which we can just rewrite as minus x plus 3. You can write it the other way around if you wanted to. You could write it as plus 3 minus x or 3 minus x, that's fine, but this is a perfectly valid way of expanding these brackets up here. So what if we've got to deal with multiple signs and multiple things? To begin with, hone your attention in on the brackets. Forget about this plus 1 here. Ignore it. Focus on expanding the bracket first. 2 times 3 and 2 times x. Then bring the 1 back in. So this is 1 plus 6 plus 2x after you've expanded the brackets. 1 plus 6 you can bring together to give you 7 plus 2x. Down here, again, we've got to remember what the negatives meant. Minus 2 times 3 becomes minus 6. Minus 2 times minus 2x becomes plus 4x. So to begin with, we have 7, take away 6, plus 4x as discussed. 7 take away 6 is 1, and you'll notice that the 4x just sits on its own at the end quite happily. What about this one? This is where things start to get a little bit unnerving. We're looking at just letters now. These letters could represent absolutely anything, and that can become a little bit scary. We take our time with it, and in fact what I'm going to do, the answer will be revealed, but I'm just going to go through it in the pen so you can see how I would work it out myself. A times A, that's going to give us an A squared. A times negative B, that's going to be a negative AB. Minus B times B, that will become a minus B squared. And minus B times minus A becomes a plus AB. What do we notice about that? Well, A squared, this comes back to simplifying expressions, which I did a video on a few weeks ago. If you look it up in YouTube, it'll be sat there as one of the first ones we ever did. A squared doesn't see anything else. There's nothing else like A squared. This minus AB and this plus AB, they will cancel each other out, leaving us simply with A squared minus B squared. And down here, again, I'll just do it in pen so you can see what's going on. 3x times 3x, that will give us a 9x squared. 3x times negative 4, that will become a negative 12x. Over here, let's remember that we can treat this as a minus 1 times everything going on here. Minus 1 times 5 becomes minus 5. And minus 1 times minus 2x becomes a plus 2x. The bit where a lot of people can get a bit confused at this point is how we deal with the negative values. To begin with, the 9x squared is going to sit on its own. This minus 12x, we're going to link it with the plus 2x, and we only need to think about that. Minus 12x plus 2x. If you were to go way back to sort of late primary school or lower high school and think that minus 12 plus 2, it's minus 12 degrees plus 2 degrees, that becomes minus 10 degrees. In the same way, minus 12x plus 2x becomes minus 10x. Okay, so hopefully you've had a bit of a go at the questions up here, paused the video and so on to have a go at it. What you should have got from the first one, 11 times 4x squared, 44x squared, 11 times 3y, 33y, and 11 times negative 2 to get negative 22. None of that needs combining. What about the 5 plus 3x minus 1 and so on? 5 times by the 3x, that would give us 15x. 5 times negative 1, minus 5. Minus 4 times 2 is 8. Minus 8. And minus 4 times minus x would give us a plus 4x. Can we simplify that? Absolutely, of course we can. 15x plus 4x would give us 19x. And the minus 5 minus 8 would become negative 13. What about this third one down here? 5 take away 4 lots of something. So I've just ignored the 5. I've kept it where it wants to be. Minus 4 times 2 becomes minus 8. And minus 4 times minus x, again, becomes plus 4x. 5 take away 8 is negative 3. And the plus 4x doesn't see anything else, so we are looking at minus 3 plus 4x. Alternatively, you can, if you prefer to have a positive at the start, rewrite it as 4x minus 3. Both of those are the same way to write this expression, and either of them would be perfectly valid. So up here, I'll just reveal the answers that we've got for both of them. 19x minus 13 as discussed, and 4x minus 3. The note that's just hidden under here is what I've just discussed, the fact that you can write these in exactly the same way. If you want to think about that in a bit more detail, by all means, if it's still confusing for you, by all means, give it a mention in the comments. So up here we have the exercises. What I will do is set a little timer going just in the corner somewhere so that you can see when I'm going to reveal the answers. What I will do is reveal the odds and the evens for part 1 and 2, and then I may be kind enough to give you a little hint for exercise 3. The hint comes in the following form. The first one shouldn't be too tricky for you. The second one you're going to want to do a little bit of work because you are in fact looking at 2 different rectangles. Try and use that as a bit of a hint. Otherwise, I'll reveal the answers to you in a bit. And that, folks, is it for today. Very, very well done, especially if you even got halfway through question 4. That is from the International Maths Challenge, which is usually put forward for anyone who is absolutely top of their game in years 7, 8, 9, 10 and 11. Really tricky stuff, but if you even got halfway into it, incredibly well done. Again, if you want me to give a bit of feedback on that, / give you the general solution, please give it a mention in the comments. Otherwise, if you got through question 1 and you're really happy with what you got, then well done, you're an absolute superstar. If you got through 1, 2, 3 and had a good go at 4, brilliant. If you had a go at it, if you've been trying your hardest, if you understand just a bit more than you did before, then you are an absolute legend. Well done.
And that is it for this video, ladies and gentlemen. Thank you so much for watching. If you think it helped you out with your maths revision at home, then please click subscribe to get notifications on future videos. Share it with a friend if you think it will help them as well. There is a PayPal account, but please don't feel obligated to do that. 10 or 12 pence if you think that it's worth it for you at home and you liked the video and the content that I've put out. Failing that, thank you so much to Dr. Frost Maths for the slides, for UTC South Durham for inspiring these videos, and most importantly to you at home for watching. I'm David Myers. Take care.